students, this is the second video of dimensional analysis, and this one can be done either in a two-step manner or in a one-step manner, depending on your preference. I don't know if you noticed, but when we were doing the problems in the prior video, we always went through one of the base units. We either started with a base unit or we ended with a base unit. But that's not always going to happen in life. Things are not normally that straightforward. So now what we're going to do is we're going to go from any unit to any unit and not necessarily through the base units. So let's just jump right in and let's start with this first problem right here. This problem right here says convert 2.4 times 10 to the fourth milligrams to kilograms. So we're going from milligrams to kilograms. Okay, so if we go up to our prefix table and we look, we have milli right here. There's milli, 10 to the minus 3. And then we have kilo right here, and kilo is 10 to the positive 3. Now there's one or two ways to do this. The first way is to do two steps where we're going to go from milligram to gram, milligram to gram, and then gram to kilogram. So let's do it that way first, okay? So I'm going to go from milligram to gram and then from gram to kilogram. So I put down my given. And I put down where I'm going. And then I'm going to, if I have milligram here, I'm going to put milligram here. And then I want to go to gram because that's my base unit. And then if I have gram here, I want to put gram here. Why? Because I want them to cancel. And then I'm headed to kilogram, so I'm going to put kilogram there. Now look what I just did. I went from milligram, which cancels with milligram, to gram, which cancels with gram, and I'm left with what I want. So now you can see that I have two conversion factors. I have two conversion factors. Here's my first one, here's my second one. And then I just do this like I showed you in the last video. The big one gets the 1. Milli means a thousandth, but it takes 1,000 to make 1. And then in this one, kilo gets the 1. Kilo means 1,000, so it takes 1,000 grams to make 1 kilogram. And now what do I have? I have 2.4 times 10 to the fourth divided by 10 to the third times 10 to the third. Well, 10 to the third times 10 to the third is 10 to the sixth, so this is 2.4 times 10 to the fourth divided by 10 to the sixth. And then when I divide with exponents, I subtract them. So my final answer is going to be 2.4 times 10 to the minus second kilograms, and I'm finished. All right, so for some students, doing it this way is ideal, but for others, they get kind of lost in the weeds with all of the conversions. So I'm going to show you another way how to do this problem where you don't have to do two steps. You just have to think a little bit more when you make your conversion factor. Okay, once again, we're doing the problem and we're converting milligrams to kilograms. So we're doing this problem again, just a different way. Now, once again, we're going from milli, which is 10 to the minus third, to kilo, which is 10 to the positive third. So if I look on a number line, I'm right here at milli minus third, and I'm going to plus 3 kilo. So how many spaces of 10 or how many powers of 10 difference is that? 1, 2, 3, 4, 5, 6. That means I have 10 to the 6 powers of 10 difference when I go from milli to kilo. So, therefore, I can say that there's 10 to the 6 milligrams in a kilogram. Okay, so keep that in mind, and let's write down our given. Milligrams. And now I'm just going to go straight from milligrams to kilograms. Kilo is the big one. The big one gets the 1. And remember, I just showed you on my number line, boom, 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 that there's 10 to the 6. It's a difference of 6 powers of 10, so there's 10 to the 6 down here. Now, if you look up at this one, oh yeah, it is 10 to the 6 because this is 10 to the 3 times 10 to the 3, which is also 10 to the 6, and math always agrees with itself, which is the wonderful thing about learning things in multiple ways. Now I just have to divide 2.4 times 10 to the 4th divided by 10 to the 6th. When I divide with the exponents, I subtract them, and I'm going to get 2.4 times 10 to the negative 2 kilograms. No naked numbers allowed. I've got to include my units, and would you look at that? This answer agrees with this one because math is like that. So this one, we only did one step. We went directly from milligrams to kilograms. The difficult part was just coming up with that number, but if you think of a number line, you're not going to have trouble with it. So let's try another one. All right, here's my next problem. This next problem says, convert 3.56 times 10 to the 11th nanoliters to megaliters. So we're going all the way from a billionth to mega million. Okay, so let's look on our chart. Nanoliters to megaliters. So we're starting at 10 to the minus 9, and we're going all the way up to 10 to the 6. Now, if we wanted to go through grams or through liters, we would stop here and then we would go. But we're going to go direct because I'm finding that students seem to prefer the direct route, although I will show it to you twice once more. But we're going to do the direct one first. 10 to the minus 9 to 10 to the 6. So if I look at my number line, 10 to the minus 9 to 10 to the 6, that's a whole bunch of jumps. This is 9 jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is 6. 10, 11, 12, 13, 14, 15. So there's a difference of 15. So my students say to me, Mrs. Arrington, why can't I just say, get rid of the negative, 9 plus 6 is 15. You can do that, but the problem is when you learn gimmicks, if you don't understand why you're doing them, you can get confused later on when you're in a high-stakes environment like a test. So understanding why it's 15 spots is much more important than just randomly saying I'm going to get rid of the negative 9 and say 9 plus 6 is 15. But anyway, using my number line, I say that it takes 10 to the 15th nanoliters to make 1 megaliter. Okay, so that's going to be my conversion factor coming up. So let's put down our given. 3.56 times 10 to the 11th nanoliters. And let's go from nanoliters to megaliters. Remember, here's my conversion factor. The big one gets the 1. We just worked out that there are 10 to 15 of these. So now I'm dividing because this line means divide. So I'm going to say 3.56 times 10 to the 11th divided by 10 to the 15th. When I divide with exponents, I subtract them. So this is going to be 3.56 times 10 to the 11 minus 15. And that's going to give me 3.56 times 10 to the negative 4th megaliters. And that's my answer. Now, some students struggle with coming up with this number. So they want to see the two-step method. So I'm going to show you the two-step method. In the two-step method, we're going to go from nanoliters to liters and from liters to megaliters. Okay? So I'm going to draw a little map here. We're going to go from nanoliters to liters and from liters to megaliters. All right, so let's put down our given again. 3.56 times 10 to the 11th nanoliters. Now I'm going to go from nanoliters. I have nano there, nanoliters to liters. And then when I have liters there, I need liters here so they cancel. We want everything to cancel. So we're left with what we want, to megaliters. Now I check and make sure that my units are correct. So let's check and see. That cancels with that. That cancels with that. I'm left with what I want, and therefore I've set my units up correctly. Now placing the conversion factors in. I have 2 of them, one here and one here. Liters is my big one, so I'll put a 1 there. Nano means billionth, but it takes a billion to make 1. And megaliter is my big one. Mega means million, so it takes a million liters to make 1 megaliter. Now look what we have here. Aha! These 2 guys multiplied together is going to give us what? It's going to give us 10 to the 15th like it did up there. So once again, I'm left with this divided by this, which is going to give me my same answer. So you can set it up this way, the 2-step way. Your conversion factors are easier. Or you can set it up this way. It's shorter, and it's just a little bit harder to come up with the power of 10 conversion factor. But it's your choice. All right, so I have 2 more problems for you. This one converts 7.25 times 10 to the negative 6 gigameters to millimeters. And then this one convert 8.3 times 10 to the negative 8th kilograms to micrograms. So I'm going to give you a couple of hints with them, and then I'm going to have you stop the video and work these out on your own. Let's look at number 3 first of all. Number 3 is going from gigameters to millimeters. Gigameters, we're starting up here and we're going down to millimeters. So we're starting at 10 to the 9th and we're going all the way down to milli, 10 to the minus 3rd. So quick math, the space between 9 and negative 3 is 12 units. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the conversion factor here is going to be 10 to the 12th millimeters equals 1 gigameter. And then for number 4 is going from kilograms to micrograms. Kilograms to micrograms. All right, so we're going from kilograms to micrograms. Oh, my minus 6 went away. So can you see, to go from there to there, it's 10 to the 3rd to 10 to the minus 6th. So the difference in powers of 10 is 10 to the 9th. So it's going to take 10 to the 9th micrograms to make 1 kilogram. Remember, the big one always gets the 1. Okay, I want you to pause the video and do this on your own, and then we'll come back and look at the answer. All right, let's look at this number 3 that I have right here. Okay, so in number 3, I had gigameters here, and I went straight from gigameters to millimeters. I did the shortcut method. And then, as I already told you earlier, there were 12 powers of 10 between them, so this becomes 10 to the 12th. And now this means multiply, so when I multiply with exponents, I add them, and negative 6 plus 12 is 10 to the 6th, and so there's my final answer. Hopefully you got that right. Then let's look at this one. This one I did both ways. I did the long way and the short way, so let's look at the long way first of all. In this one, I had kilograms here, so I went from kilograms to grams, from grams to micrograms. See the pattern? And then I'm left with what I want. Now, kilo means 1,000, so there's 10 to the 3 grams in a kilogram. Micro means a millionth, but it takes a million to make 1. There's 10 to the 6 of those in 1 gram. So when I multiply this out, I have 10 to the negative 8. Then I'm going to add the 3, which is going to give me negative 5th. And then I'm going to add the 6, which is going to give me positive 1. So I'll end up with 8.3 times 10 to the 1st, and you'll recognize that that's just 83. Either way is correct. All right, then I did it the shortcut method, and this one I went from kilograms directly to micrograms. When I do that, I know that there's 9 powers of 10 between a microgram and a kilogram, so this becomes 10 to the 9th. Notice it's these two numbers added together, 3 plus 6. So 10 to the negative 8th plus 10 to the 9th times 10 to the 9th, negative 8 plus 9 gives you this, which is the same as this, which is the same as this because math. All right, so that concludes our lessons on using dimensional analysis to convert in the metric system. However, when we get to the mole, we will be using dimensional analysis like crazy, and it's a lot of fun, and you can make these things very, very long. Hopefully you have a good handle on them. If you have any questions, drop a comment below, and take care. Good job.